Hello there, children. Today we are going to work on looking at synthetic division. Now these are specific problems from the book, so let's go through how this works. So first off, I look at a problem like this. Am I allowed to do synthetic division here? Well, yes, because I am dividing by a binomial. See how this is two terms here? And that exponent is 1, that coefficient is 1. So I am able to then do synthetic division. Now, how do I do synthetic division? First and foremost, you see this binomial here. The opposite of whatever that number is goes into my box. So you see how it looks like a -2? A +2 will go into my box. Now, over here, I simply have coefficients of the polynomial that I am going to be dividing into. Now, the rule is this. Whatever exponent you start with, in this case it's a 3, you need to go in descending order from that without any gaps. So if I look here, I start with an exponent of 3. Then my next exponent in the problem is a 1, and then a constant term of, well, whatever that is, in this case -6. Notice how I'm missing an x² term. It's like if you had a set of stairs and you took out one of the stair treads. It would be a recipe for disaster. Or comedy, depending how mean you are. But that's a different story. So I look here, and I have an x to the 3rd. I am going to put a placeholder of 0x² in there. That way I go exponent of 3, exponent of 2, exponent of 1, no exponent. Those coefficients go right on my list here. The first number drops down. If you want to think about it, I'm technically going to be adding 0 there. Drop the first number down. Then, once you drop this number down, you take the number you have here, multiply it by 2. Take that product, 1 times 2 is 2, bring it up to your next level, to the upper right there. Then add. Do the same process over again. Multiply 2 times 2 and get 4. Drag that product up, add these numbers together. Then take 2 times -3. Drag that product up and add. Now these are the list of the coefficients of my quotient, of the thing that I was dividing. That's my answer. Alright. Now, over here, this is your remainder. You write your remainder as -12 over the thing you were dividing by, in this case, x minus 2. This becomes my constant term. This next term becomes the coefficient of x. This next term becomes the coefficient of x². If I had another term over here, that would become the coefficient of x to the 3rd. Let's look at another example here. Now, notice this problem here. I am dividing 4x² plus 5x minus 4 by x plus 1. I'm allowed to do synthetic division here because this creature is a binomial of exponent 1, coefficient 1. So now I need to find out what my k value is. I look to see this number is a +1, so the opposite, a -1, goes into my box, so to speak here. Now I look at the thing I'm dividing into. Okay, I start with an x². Then I go to an x, then a constant term. Therefore, I need no placeholders here. Because of the simple fact I go 2, 1, and none, as it were, for exponents. So I'm good to go there. So my coefficients are 4, 5, and -4. So I drop the first number down. Think of it being a 0 here. Add 4 to 0 and get 4. Drag the first number down. Multiply that by the number in my box. So -1 times 4 is -4. Add. 5 plus a -4 is 1. -1 times 1, -1. Add. -5. Now what I do from here is I go through, and this is my remainder. If the number here, you put -5 over the thing I was dividing by, x plus 1. That 1 becomes my constant term, and that 4 becomes the coefficient of x. So let's move on. Alright, now let's try this problem. So, a little bit longer this time, I know, we'll be fine. So, am I allowed to divide this thing with synthetic division? Yes, I'm dividing by a binomial, exponent of 1, let me write those in here, and coefficient of 1. Doesn't really matter for the problem, but we know that we can use synthetic division. Now, I look at my exponents here. I go 5, 4, 3, 2, 1, none. Therefore, I am able to use synthetic division. Now, what number goes in my box for synthetic division? Therein lies the question. Well, since this is a negative 8, I will be putting an 8 in my box. Opposite of that. Now, what are my coefficients going to be? Well, the coefficient of x to the 5th is 1. The coefficient of x to the 4th is negative 9. The coefficient of x to the 3rd is 15. The coefficient of x squared is negative 52. The coefficient of x is negative 28. And the coefficient of the constant term, or just a constant term in general, is negative 35. Now, what happens here? The first number drops straight down. Straight down in the problem. Now, when that happens, I then have a little work to do. So, the first number drops straight down. It's a 1. You multiply that 1 by an 8, you get 8. Add 8 to negative 9, you get negative 1. Multiply negative 1 to 8, you get negative 8. Bring that negative 8 right up here. Then you add 15 to negative 8, and you get 7. Alright, now, with that 7, you multiply that 7 by that 8 in the box again. And you get what? 56! Thank you, imaginary voice in my head. We then add again, negative 52 plus 56, 4. You then rinse and repeat. Take 4 times that 8. You get 32. Add 32 to negative 28. You get 4. Rinse and repeat the same process over again. 4 times 8. You get 32. Add 32 to negative 35. You get negative 3. Now let's stop and think. Is this a factor? That means what I'm asking is, does x minus 8 divide evenly into that polynomial? And the answer is no. Why not? Very simply put, I've got that number right there. That number is a remainder. If that number is any number other than 0, then something isn't a factor. Like, why isn't 7 a factor of 24? Because when you divide 7 into 24, you get 3 and then 3/7, which isn't going to work. Alright, so now, how do I write this polynomial? So here's what my polynomial looks like as an answer. This negative 3 is my remainder. Now, notice I put the negative out in front there, that's fine. I divide it by x minus 8, because that's what I was dividing by to begin with. Here is my constant term of 4. This next term is the coefficient of x, 4x. This next term, 7, is the coefficient of x squared. See how my powers are going up as I go from right to left? See how I have a negative 1 here? That's my coefficient of x to the 3rd. And there's my coefficient of x to the 4th. If you think about this, it makes a little bit of sense. I started with an x to the 5th. I'm dividing out 1x over here. It stands to reason that my exponent should drop by 1, at least my biggest exponent. So I go from 5 to 4. That's going to be super helpful for me. Now, along with that, what I could do if I really felt the need to, I could multiply all of these terms by x minus 8, and it would in fact get me back to this polynomial right here, if I so choose to do so. I'm not going to in this case, but to prove a point, you could do that if you wanted to. Alright, let's do one more example here. Alright, this problem. Yes, I can use synthetic division, dividing by a binomial again. Do I need placeholders for my coefficients here? No. I went from exponent of 5 to 4 to 3 to 2 to 1 to none. So we are Gucci, as the kids say. Now, why did the negative 4 go in my box for synthetic division? Because I had a plus 4 over here. Now, what are my coefficients? 1 is the coefficient of x to the 5th. Negative 6 is a coefficient of x to the 4th. Negative 46 is a coefficient of x to the 3rd. Negative 32 is a coefficient of x, or m squared, excuse me. Negative 29 is a coefficient of m. And 16 is a coefficient of the constant term, or just the constant term if you want to call it that. Draw my little line here. Now, if you don't like this, folks, what some of you end up doing is you could do this if you so felt the need to do so. Some people don't like doing that little box. They do it this way, which, again, does it matter? Absolutely not. Absolutely not. Imaginary voice in my head. You're absolutely correct there. It doesn't matter. I'll put a -4 here. People do it like that. Your choice. Your book shows it both ways. Now, we drop the first number down, or you can consider it adding to 0 if you like. That's a terrible arrow, but you'll all manage just fine with it, because I trust you. Now, multiply, once I drop that 1 down, multiply 1 times -4, get -4. Add, you get -10. Multiply -10 times -4, you get 40. Add, you get -6. Multiply, you get 24. And then add again, you get -8. Now guess what we do? I'm going to add these. 4 times -8, -32. So it'd be positive 32. Add, you get a positive 3. When you multiply 3 times -4, you get a -12. Oh no, it's a different color. Oh well. And then add these up, you get 4. Now, what is my answer going to look like? This is my remainder. There's my constant coefficient, my x coefficient, my x squared coefficient, my x to the third coefficient is -10, and my x to the fourth coefficient, or excuse me, m to the fourth coefficient is 1. What that looks like in a polynomial is this. So the m has a 1 coefficient, m to the fourth, the -10 goes to the m to the third, -6 goes to the m squared, the -8 goes to the m, the 3 goes to the constant term, and the 4 is divided by whatever I was dividing by in the first place, m plus 4. I hope that is helpful, gang. Now go henceforth and do commence.